Problem number 8 from the Chapter 3 quiz review states, a fresh sample of barium-122 weighing 80 grams was obtained for an experiment. The table below shows the amount of barium remaining in the sample over time. So we have time here represented in minutes, and we've got the amount of barium in grams. So we can see here that, we've obtained 80 grams to start, but then as time goes on, every 2 minutes there, right? Every 2 minutes that goes by, right? It goes through a half-life there, right? For 2 minutes for one half-life, because it cuts down to half from 80 to 40, from 40 to 20 there. So every 2 minutes there, it goes through one half-life. Okay, so letter A says, what is the half-life of the substance? Well, I guess we just answered that, right? It's 2 minutes. So letter B then states, if it takes 10 minutes to set up the experiment, how much barium will be left when the experiment begins? Well, as we continue to work our way across, every 2 minutes there, right, we're losing half of our barium. So let's say once we got to 8 minutes here, it would be half as much as it was at 6 minutes. That would be, 5 grams? And then when we go another 2 minutes, it's going to cut itself in half again, so that should leave us with 2.5 grams. So there should be 2.5 grams left when they start the experiment. So write an exponential equation that models this data. Use your equation to find the amount of barium-122 remaining after 3 minutes. Okay, so what we're looking at here is an exponential function in the form y is equal to a times b to the power of x. Now we already know what a is. A, right, is when our time is at 0 there, so that's what our starting value is, 80. So we can go ahead there and think about plugging that in already. We have y is equal to 80. Now because it's a half-life, right, our multiplier is going to be 1/2. And then we're going to have to take our time increment here, right? So when I multiply 80 times 1/2, we get 40. But, that's 1 half-life, but it's 2 minutes there. Right? So every minute we plug in there, 1 minute would be like half of a half-life. So we're going to have to take our time increment and we're going to have to divide it by 2, because it's every 2 minutes we go through 1 half-life there. Okay, so our equation is y is equal to 80 times 1/2 raised to the power of x divided by 2. This isn't the only answer for the equation. You could also take it there and set up your chart, and I guess we already have a t-chart set up here, right? And you could take your value of A, and I'm going to do this over here on the right side, so maybe you can see it. Right now we've got, A is equal to 80, and we could just take another point. Let's take the point 240, and we could plug in our 40 for Y, and then our 80 for our A. We don't know what B is at that point there. We know it's going to end up being something like 1/2, but if we do it this other way, our multiplier won't be just 1/2, and I'll show you what I'm talking about here if you're wanting to listen along to this. Otherwise, fast forward. So we'd have this would be to the power of x, and our x is actually 2 on this one. So in order to solve that, we'd have to divide both sides by 80. So we get 1/2 is actually equal to b squared. So then we'd have to take the square root of each side. And since we don't have to worry about negatives, b would equal the square root of 1/2. So another way you could have written this equation here would be y is equal to 80 times the square root of 1/2 raised to the power of x. These are equivalent. So either one of those could work. Just depends on which way you see it, which way you're most comfortable. All right, so they wanted us to find the amount of barium remaining after 3 minutes. Well, that means we're just going to take it and we're going to plug in 3 for x. So Uh-oh, did my pen die? Come on, pen, come back to me. So here we go. Sorry, I was just trying to see if I can get the pen to work again, and it's not working still. This is awesome. iPad's not working either. All right, maybe we're back. There we go. All right, so sorry, technical difficulties. Here we go. So we're going to say y is equal to 80. This is still for part C, times 1/2 to the power of 3/2. And when you plug that in there and you simplify it down, you should get that this will equal about 28.2842 grams. And when you look up at your equation there, right, 3 would fall somewhere in this range, right, somewhere around in here. So that answer there would make sense. It should be somewhere, between 20 and 40. And then the last question there asks us, when will the sample be gone? That is, when will the amount be 0 grams? And honestly, the answer to that would probably be never, right? Because if we keep cutting something in half over and over and over again, we should not ever end up with an amount of 0 as the output there. If you think about your exponential function there, and I think my pen died again, so hold on. If you think about your exponential function, y equals ab to the x, right? Because this one has we'd hit our y-axis at 80, and then it's coming down by halves, right? And then it's going to come down. But remember, there's this asymptote along our x-axis here, so it does not ever touch that asymptote there. So therefore, it's never going to have a y value equal to 0 because it can't. But so basically, when will the amount be 0 grams? It will never be. It can't be. All right, hopefully that helps make sense. If you don't like my explanation, go talk to your chemistry teacher. Haha. All right, bye.